context-free grammar. Before we talk about context-free grammar, we have one important question. What's grammar? I don't mean your grammar, and I also don't mean English grammar. I'm talking about computer grammar, language, as per programming language, logic, all these things. So, grammar are a set of rules for defining valid sentences in a language. Let's use English for example. I like mango a lot. Why in heaven's name did I just whip that sentence out, and why does it make sense to you? It's because of grammar. I could say I mango a lot. Like, this is not just a set of words. No, there are rules that make us understand stuff. Otherwise, everybody will be confused, including myself. So these help us to define reasonable sentences in a language. Now, what are the components of a context-free grammar? Number one, we have the terminals, represented with VT. These guys are the symbols that form the strings of the language. They have to be finite set of symbols that form strings in a language. The me, the you, the I, the T, those are terminals. Then we have the non-terminals. And we call those things terminals because they come to an end. There's no lesser copy. There's no lesser. They can't be broken down any further. That's why we call them non-terminals. Now, for non-terminals, on the other hand, these guys, denoted by Vn, these are variables. They're a finite set of variables. And variables can hold a value. These ones are the ones that can be broken down into either other non-terminals or terminals. So, in any case, moving on, we have the start symbol. Unlike English language, we need some kind of anchor for our grammar to survive in computer science. So the start symbol becomes the representation for the language, right? So the start symbol represents the language. We denote that with the S. Then one last thing is number 4, the production / the rules. These bad boys are the reasons why we can actually make strings. So we denote them by this, which means derive, right? Having said that, terminals, the non-terminals, the start symbols, these are the components of a context-free grammar. And you should note that you should define this when you are addressing a problem. Okay, when they say there's a CFG, we want you to represent it. You are supposed to define the CFG based on the components, the terminals, the non-terminals, the start symbol, and the production rule. Once you do that, you then already give a foundation to your solution. So do not, I might make some mistakes here and there and actually skip that. But in the case of an exam, you do not want to make a mistake of jumping straight to the solution and not defining what you are actually solving, which in this case is a context-free grammar. Derivations. These are the ways we actually we get strings. This is how we get strings, by the derivations. And derivations can happen in multiple steps. We can have 0 or more steps. Let's just say we have maybe 5 steps, maybe from alpha to beta in 5 steps. So we derive these in 5 steps, and these could be they could be terminals or non-terminals. I'll come to sentential. Let me just go there then. Before that, I should talk about the language of a CFG. The language of the CFG. If G is a language, is a CFG with the following components: Vn, Vt, S, and P, which is the set of non-terminals, set of terminals, the start symbol, and the production / rules, such that we have a language. We have a language L, denoted by LG. This is a set of terminal strings. Terminal strings. That should be underlined. Terminal strings, meaning VT. That means the language of a CFG should not have non-terminals at the end. That means that's what it's accepting. If you look at DFAs or NFAs, you know that there are some strings that will be accepted and some that will be rejected. Now, what this CFG is going to receive is a set of terminal strings. We are coming to sentences, but before we come to sentences, to understand the language is only having terminals. Note that. Let me go on. Such that we have L of that grammar, the language of that grammar represents, there's a string W, which is an element of the non-terminal set of non-terminals, where S is the S derives, which is the start symbol, derives the string of terminals in the grammar in 0 or more steps. That's what we have here. We have G, which is the context-free grammar. We have the language of that context-free grammar. Now, the language is a set of terminal strings, and then mathematically, LG is equal to W, which is a string, which is an element of the terminals, and we have S, which is the start symbol, derives that string in 0 or more steps in that grammar. Now, coming to sentential forms. Sentential forms are not the same as the language. If we have G, which is yada yada yada, Vn, Vt, S, and P. Okay, so if we have that, the sentential forms are just having not just the terminals, they are also having the non-terminals. Yeah, so we have G is this guy. This is CFG. Any string with called alpha, let's just call it alpha, which is in the set union of the terminals, set of terminals, and the set of non-terminals. Yeah, such that S, which is start symbol, derives alpha at any number of steps, is a sentential form. Basically, what this is just saying is we have a context-free grammar. Yes. Then there's a certain string alpha, which can be a combination of terminals and non-terminals, or non-terminals or terminals, such that the start symbol can derive that string at any amount of steps. Could be 1, 5, 20, 1 million. What happens with that is we've created a sentential form. This alpha is a sentential form. That's all. It's just that simple. Moving on. Let's talk about Backus-Naur form. Bacchus Noir form, which sounds like a classic wine for some reason. Bacchus Noir form. This is BNF in short. This is just a shorthand for writing production, like for writing CFGs. Shorthand for writing CFGs. You want an example? Okay, we have S derives B A, S derives B A, S derives B B, S derives B B, S derives A B B, S derives S A B, and so on and so forth. You realize that this can be a little stressful to do, right? And we do not want that in many cases. So to save space and time and common sense, we are just going to have BA slash BA slash BB. Then you can have that again, BB slash AB slash SAB. Isn't that just wonderful? So this saves us a lot of time and effort. This creates stress. This creates stress. And that's just Bacchus Noir form. Now let's attempt some questions. Okay, let's say we have an example. Consider the grammar G, V, T, V, N, S, and P. We all know what that is now. Where Vn is S. So the only non-terminal is the start symbol. And Vt is A and B. And they gave us the production rule. P is S denotes or derives rather ASB using the Bacchus Noir form, derives AB as well. Now we're told to show how a a to the power of 2 b to the power of 2, the string is formed, is derived rather. Also determine the language. How do we go about this? We'll use, I mentioned that the S is the representation of the entire language. So this guy kicks off everything. So starting first, we will use this production rule. Why? If we start with the terminals first, what will happen is we cannot generate newer strings from this. We cannot, because it doesn't, it's terminals. Terminals cannot be broken any further, but S can be broken further into ASB and AB. So S gives us more opportunities to create more versions, but AB, which are terminals cannot create new things. Terminals end. That's why they're called terminals. Think of it as terminator. Never mind. So we have ASB. Okay. How do we get to A to the power of 2, B to the power of 2? All we need to do, we are not going to reintroduce ASB again, because that will be, it will create a situation where we'll have only the sentential form, AASBB. Now, this is not a language. This is the sentential form, which means that I'm still supposed to do something else. But if I try to then terminate this by adding AB, we will have AAA, BBB, and that's not what we are looking for. Okay, so then sorry about that. We are going to have A, then the next production rule is AB, so we just have the AB and B, right? So expanding that, we have AB, AB. So this is A to the power of 2, B to the power of 2, which answers the question of how this is derived. But this doesn't tell us how this language is formed. So let's go again. We have S derives ASB. Now we can keep on expanding, right? Let's say we expand again. ASB, B. Expand again, A, S, B, B, B. You can expand again, A, S, B, 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 B. Because of this S, using the first production rule, we can keep on doing that till we have at a strange amount of steps an minus 1, bn minus 1. And we can derive that one more time and get an bn. There we have determined the language, and this checks out. Moving on to the next example, maybe I'll call it a day from here. Say we have another CFG, a context-free grammar. So the CFG generates strings of balanced parentheses. In programming, if you have results, say you are writing a code, x is equal to result to the bracket I result, and then you have the quote and this isn't there, what happens? It will return an error. Why? Because it's missing a parenthesis. So you can tell the importance of grammar already. Why? We are generating a balanced parenthesis constantly. We can generate any amount of it. We can generate this, we can generate this, we can generate this, we can generate this. It will always be balanced regardless of what we do. And how do we do that? Let's find that out. So I said you have to define what you are doing, right? So let G be the CFG. And what is the component of CFGs? We have VT, VN, S, and P, right? Now, we have the freedom to determine what is what, but then in an exam, your freedom better leads you to the right answer, or that's bondage. VT is a set of terminals. Then what are the terminals we need here? We need the open and the closed parentheses and maybe the empty. What are the non-terminals we need? We just need a start symbol. We're not doing anything too flashy. Then we have the production rules. What are the production rules? We have to determine that. So how do we go about that? Recall that we want to create, let's just look at some examples. We want to create something like this, something like this, something that can do this, right? So how do we go about creating this? Easy. Let the start symbol, which is the representation, be able to create a balanced parenthesis upon starting. You should be able to create a balanced parenthesis, right? So what this naturally does is that I can have S, then I can have S again, then I can have S. So this can expand to give us multiple dimensions of this, and that's what we want. However, we cannot create this from this guy, right? Because there's no way to duplicate. So what do? We create another production rule that we have S. So S can duplicate. Bless me. S can duplicate, right? So from there I can have more copies show up by expanding this to this. I can have more copies show up by expanding this to this to this. So I can expand and have multiple copies now. That deals with what I was looking for. So what remains? I would never be able to end this thing if I do not have this terminal, which is the empty. Because when I do this, then I do this. I'm just going to keep having sentential form. I've not gotten to the language. So when I can introduce the empty, I will now have the balanced parentheses only, and that's what I'm looking for. So this is confirmed, right? Do you want to test it? Let's go ahead. Let's say we have parentheses of this, so we should test this out if it works. S, which is the representative, derives S. Take a look at this. We need 2 copies, right? So we're going to have to do S and S again. That is this. We started off with this guy. You don't need to start with the first one. If I went ahead and started with the empty, there will be no basis for deriving anything else. But I started with this so I can then derive this guy. So what do? I can introduce the parentheses to this guy. So we have this, then we have this, right? So I can do the same for the other guy. Then we have this. But then there are 2 sets of balanced parentheses there. So we are going to have to do one more for the other guy. So I'm going to recall this again. So we have that. Now what do? I introduce the empty, one after the other. The computer will do it one at a time, not randomly. So we'll have this. In the end, we would have this and this, which is what we are looking for. So that checks out. Hope you enjoyed this course. I might do some more videos, don't know, but bye for now.